Hi, today we'll go to performing an assisted web app pen test using Pentest-Tools.com. We'll go from knowing just our scope to delivering a finished report to our client using Pentest-Tools as one of the tools in our arsenal. This is our target for today. It's a website for a security firm. We have some functionality here, like a blog, the ability to create an account, and there's some functionality hidden behind the login. There's a contact form, a way to subscribe to the newsletter, and probably some other things which we'll discover when we go to our recon. To start things off, we'll create a new workspace. We'll call it Security Guards, and we'll add our target to this workspace. We'll start off with some light recon of the target to see what runs on it. And at the same time, while this scan runs, we'll do some light spidering of the target. For this, we'll run a custom scan. We'll disable most of the things apart from the spider, because the only thing we want at this stage is to get an overview of the target. We'll let the spider decide by itself which approach to use, either the classic or a single page application. 10 requests per second sounds like a good start. A spidering depth of 5 seems good. We won't place any restrictions on the included or excluded URLs at the moment. We don't want to scan any of the subdomains that we find on the website, and we'll disable all the active checks for now. We can let the passive scanner run, as it only looks at the requests that the spider makes. So let's start the scans as well. In the meantime, I noticed that the recon for the website is ready, so let's have a look here. The first finding tells us what technology stack the website uses. So we can see that it uses a CDN, it uses Bootstrap as a UI framework, it seems to be placed behind Cloudflare, and it uses Nginx. Let's add a few of these things to our notes. I use Obsidian and a really simple template, and let's note down the technology stack. So what's interesting here is Nginx for me, Cloudflare if they use it as a WAF, and the jQuery version. I mentioned previously that they might be using Cloudflare as a WAF. We have a way to test for that, and we'll do that now. This will help us later when considering whether we have to rate limit the requests that we make, or if we have to use any kind of encoding or WAF evasion for our payloads. We have a recon tool for that. There's the WAF detector, and we'll run it on target. In the meantime, let's go back to our website scanner and see what the custom website scanner found. So we can see that the session ID is missing an HTTP only flag. This might prove useful if we find any XSS later. The session ID is missing a secure flag as well. There's some mixed content, some missing headers. The website doesn't define any CSP, so this means that exploiting XSS will be easier. There's an email here, but it seems to be just a dummy one. Then there seems to be a comment at the contact page. So there's something that might be vulnerable to SQL injection here. We'll have to take a look at that later, but let's note this down. Let's take the route. Let's create another section here for future work. And the first entry here will be to take a look at the contact section. There's a login interface, but we already know that. And here are the spider results. These might be the posts on the blog, but for some reason they don't seem to work. And it seems that posts are editable, which is of interest to us. Let's note that down for our recon. So we have the blog, and anyone can edit posts. This is a vulnerability by itself, so let's note that down as a draft, and we'll come back to it later. Instead of doing this here in the notes, where I'll just write 2 or 3 words, I'll do it in Pentest-Tools, so we can come back to it and have a more structured finding later. But first, let's note a few words here. Let's open the findings page. And we seem to have quite a few findings here, but we don't really care about them. We'll use a template for this finding, and the closest things that we can use is the broken authentication. This is an authorization issue, but it will do for now. Let's rename it. The blog posts are editable by anyone. We verified this. This is for this target. Instead of broken authentication, we'll use authorization. And the issue here is that we should have some sort of authorization check on this action of editing a blog post, but we don't have any, and anyone is able to edit the blog post. So let's note that down. So broken authorization happens when an action that is supposed to be protected by an authorization mechanism can be performed and we'll come back to it later to add more evidence, how to reproduce, and other kind of information. We'll just save it for now. And you can filter these type of findings that we added ourselves by using the manually added source. Okay, let's go back to our scan result and see what else we have here. So there's 2 blog posts, so there's more entry about these things. We already saw the blog, the contact. create. Let's see what this does. So we can create a new post without authenticating. Okay, we'll come back to that later. There's a search endpoint that we didn't really see linked on the website. Let's note this route down. So this services page doesn't really seem to do anything else. Okay, now that we have a few routes that we can look at, we can do few things. The first one is to try to expand our scope just a little bit. We can do that with some fuzzing to try to find some unlinked endpoints. And the second thing would be to try to take a deeper look at these endpoints that we've noted here. I'll start a scan for fuzzing, and we'll try to look at the endpoints manually for now. We will use our URL fuzzer, and we want to fuzz the path, the URL path. Let's use a deep word list. We don't want to use any extension. We want to enable recursion. So when we find an endpoint, we fuzz that from there on down. The retry options look good, so let's start the scan. While this scan runs, I said that we would look at these endpoints manually, but there's one other thing that we can do. So we can go to the asset page and add these specific endpoints as other assets and scan just those with the active scanner part of the website scanner. So we won't spider them anymore. We will just look for vulnerabilities in those endpoints, and let's see what we can find. So we'll start off with the search. And we'll continue with the create endpoint. And let's use the first post for the edit functionality. So we want to scan all of them with the website scanner. Again, custom scan. We want to disable the passive scanner and just run all of the active detectors on it. Let's look at the URL fuzzer. We have not found anything so far. So the scanner has found an enumerable parameter, but we already knew that. So we have an XSS here. Let's take a look at the request first to see what happens. So when we post to the create endpoint and we inject inside the title parameter, the content in the title parameter seems to be interpreted as HTML. So let's take a look at this manually. We can use the replay attack button. Okay, and we have an alert. So let's see what happens. We seem to have broken the HTML here. So insert some dummy content in the post and in the reference, and let's take this payload here. Okay, so what this payload does is that it closes the title tag, so I assume that this will land inside the title, and then it uses a CVG load event to execute some JavaScript. So let's double check this by popping the domain in an alert. Okay, so that works. The problem here is that this post doesn't really seem to be created. The website breaks when we get the response back, and there doesn't seem to be a new post here. But something that comes to mind is that the edit functionality might be vulnerable to the same thing, so let's test that. Let's take the same payload here, and we will go install our proxy. And let's use the same payload first, see what happens. The website seems to break, but let's see what happens when we visit the website. So the rendering is broken, but there seems to be something happening here. So let's take a deeper look at the response. We'll go on our proxy in HTTP history, and let's take a closer look here. So we'll just put some test content here, and let's use a simpler payload. Start off with an image, and let's see what happens. And let's put just a random attribute here that we can search for. Okay, so we can see that our input is inserted as HTML inside the title tag, so we have an XSS here, and this we can actually exploit. It's a stored XSS, and going back to the previous finding that we had about the session cookie not using the HTTP only tag, so we can abuse this XSS to steal the session cookie of anyone that visits this blog post. So this is a pretty powerful finding. So what I'd like to do now is to go to the findings page. Let's filter by this target. The XSS has a high risk level, and what I want to do is to first take a look at the default finding and see if there's anything that I would like to change here. We can simplify this evidence, and we'll do that in a moment. So this part here doesn't apply to us. We don't really require social engineering here, just that anyone visits the affected blog post. But this vulnerability is further enhanced by the fact that there's no authorization on editing a blog post, so we can edit all the blog posts and put an XSS payload on each and every one of them. So let's go back and let's duplicate this one. Okay. And I like to change the status for this one as, let's say, accepted. Or no, better yet, let's ignore it and we'll use the copy that we make. Okay, so let's edit this. The first thing is that this is a stored cross-site scripting, so let's change the title. It's verified, the endpoint is correct, the impact is high indeed. Okay, so let's simplify this evidence here. So the simplest way to explain this is that the title of a post is rendered as HTML when a post is viewed. So as a proof of concept, we'll use the classic alert payload, but we'll go into further details about the impact in the risk section. So let's know that. So as a proof of concept, if we insert the payload so let's go back to editing our blog post. So let's take a picture of this first page where the input is sanitized and paste that here. Let's note that the input is sanitized when the title is sanitized. Go to the how to reproduce section. We'll just know that go to any of the posts at /blog and insert the payload script earth inside the title. Okay, then after that you have to click on submit. So let's take a picture of this here. Okay, and add an arrow to the payload. I'll have to buy shutter at some point, but today is not that day. So as I mentioned before, we said that the risk is even greater here because of two reasons. The first one is that is a stored XSS. And the second issue that makes this vulnerability even higher risk is that there's no kind of authorization on editing a blog post. So this recommendation is pretty generic. We can do better than that, but for that we'll have to try to find out what the backend library is, and we can give some more precise recommendation. But for now, this will have to do. Okay, great. Now let's go back to our scan and see if we have any more findings. So all the scans have finished, all the website scans have finished, and we seem to have a high risk vulnerability for each of them. So we started with the edit endpoint. We already know that. I think the sync is the same for the create and edit endpoint, so we've covered this one. It seems there are two vulnerabilities inside the search endpoint. So the first one is a SQL injection. So the website doesn't seem to use parameterized queries and neither an ORM. The backend database seems to be SQLite. And we have some new recon information here. The application uses Workzoik, which implies that the backend language is Python. So let's note that down. And this implies some future work for us. We'll have to find a good sanitization library. HTML sanitization skipping library in Python to recommend to the client. So let's take a look at this request and see what happened. So it's in the search endpoint. There was a single quote injected. Let's try and replay this attack. Okay, we have the option to exploit this with the SQLi exploiter, which uses SQL map. We don't want any Boolean queries, neither time-based blind. Okay. So let's run SQL map and see what we can find about the database schema. While that runs, let's take a look at the other finding, which was a Python code injection. So this is interesting as well. So the same query body parameter seems to be evaluating the input as Python code. So what this payload does is that it makes a request to more or less this URL here, but the domain name is replaced with ptlogger.net. And when this payload was evaluated, this logger received a request with this user agent and these headers. Okay, so this is definitely interesting. We'll come back to this code execution. Let's see what the SQL exploiter did. So it found 3 tables, post, users, and something specific to SQLite. Okay, so we have one table shown here, the users table. So this implies that the post table was not extracted. And we managed to extract some usernames and passwords. We'll add this to our to the finding information later. But first let's check if we can crack any of these passwords. So it seems that Bonnie and Bonnie2 have the same password. So let's go to our terminal. And let's try to crack these passwords. Okay, so this is the first one. And this is the second one. John, that works. So we already found the password. Let's run John with show. So let's see which user had this password. Let's try to log in. Oh, the username is Bonnie. And the password was QWERTY. Oh, this does not work. Let's try the same thing for admin. So I have the password to our admin user. Okay, let's start to add some of this information to our finding. Going back here, so the finding was about the search endpoint. So it's this SQL injection here, and we'll do the same thing. We'll clone it. Let's filter just by this endpoint and high risk vulnerabilities. Okay, and again, mark this as ignored. The reason I'm adding this information is that if you're working in a team, you can see all the changes that anyone did to a specific finding in this view right here. So let's go to our copy, remove the copy. Okay, let's use just this evidence here and delete the rest. And now let's add some information about the data that we got out of the database. We won't add neither the hashed nor the cracked password here, as it's not really a good practice. But we will note down that the admin password was crackable. Now we'll add some data information about reproducing the findings. So first, we have to go to the search endpoint. For the recommendation here, this one seems to be using a PHP sanitization function, but we want to give a recommendation for Python since this is what our user has. They seem to be using the default SQLite package in Python, so let's go to docs.python.org. We will try to find the correct way to use to make a SQL query in the latest version of Python, but you can communicate with the client and adapt the finding to his the specific version that he uses. Okay, and here we know that we are executing something, so we are looking for the execute function. Okay, so as we can see here, you can use a parameterized query here and pass the parameters as the second argument, and we will recommend that. So let's copy this query. Okay, so this is saved. Let's take a step back now and note what we've tackled so far and what are the future steps that we have to do. You know that we have an XSS in the title of a post. We already mentioned that anyone can edit posts as a cause for the higher impact of the XSS. See per injection in the query body parameter. So this leaves us with our Python code injection, and let's note that down. Since we're using Pentest-Tools, this leaves us the fun task of trying to get a shell using this Python code injection. So let's try and do that. First, let's try and repeat this request. If I remember correctly, I don't remember correctly, we didn't have it in Caido. So let's go ahead and make it. It should be this one right here. And let's try and reproduce the findings. Let's close some of the tabs that we have here. Let's use interact sage to reproduce. Okay. Actually, we don't need that since the out-of-band interaction was made using HTTP. We can use the HTTP request logger in Pentest-Tools. Let's create one for the Python code injection. The label is not good. Let's change that. Okay, so let's take this payload right here. Let's use the URL encoded form that has worked. Okay. Again, what this payload does, it will import the URL lib that request module using the built-in import function, and then it will make a request to more or less this URL right here. So what we want to do is to, one, change the URL, and two, change the final and domain that will receive the request. Okay, so let's try and replace the domain here. So let's URL decode this part right here between the quotes. Okay, let's see if that works. If we're lucky, I haven't done anything wrong, but I might have. Yeah, we're missing a parenthesis here. Yeah, so I have no idea why this is not executing, and we'll come back to this after the break. The last time we were here, we were trying to exploit this Python code injection. We wanted to validate that the vulnerability found by the scanner is actually valid and not a false positive. And the problem that we had was that we didn't manage to actually trigger a request to our logger in any way. So we will go from there, and the approach here would be to first try to simplify this payload to see that maybe there's a mistake with what we are doing to the more complex payload. And if that doesn't work, we will try two other things. The first one would be to try to change the type of protocol we are using. Here we are using HTTP. Maybe we could try to do a DNS request with some built-in Python library. And if that doesn't work, I guess our only option will be to hope that this whole request and actually that this payload is processed in the same thread. And if that's the case, we could trigger a sleep and noticed in the delay that the code executed. So first, let's try to simplify the request. So again, we'll be using the logger that we've created before. I don't really know what this replace right here on the string, what's it used for, but we'll try to get rid of it. But we'll start from the payload as the scanner made it. Maybe the encoding is messing something up that we don't really know right now. So we'll get rid of the replace on this string, and instead we will make our requests directly to this logger. Through this right here. So double check everything. So we are importing URL-request, accessing the request and then URL open method, and then supplying the URL as the parameter. Let's run that. Failure. And no, still doesn't work. Okay. On to the next idea. We'll go to the Python standard library. I think I noticed a Python tree date somewhere in the stack trace. So we'll use that. and try to make a DNS query. The search doesn't return anything, so let's try to search the web for it. So it seems that get address info from socket can do what we want. Go to the docs again, 3.8. Okay. Okay, so let's try this example. We'll try to initiate a TCP connection to port 80 on this same domain. The problem here is that our logger doesn't support DNS interactions, so we'll have to use something else. Let's try and use Interact Sage. So this is our host name, this is our payloads, and what we want to do is to import socket. Okay. I assume this is a method on the, yeah, it's a method it's a function inside the module. Okay. I assume this comments the rest of the line in Python. Okay. This is our host. No, this is our host. Okay. Now let's follow this example and trigger this connection. Okay. No space is necessary. So double check, porting socket, calling get address info on it, and in the end triggering a TCP connection, but first triggering a DNS query to resolve this hostname. Let's do that. Okay. Nope, still doesn't work. Let's see if this works in the Python repo. Let me close everything up here. Okay. This is not the same version of Python, but let's hope it works. So the reason that it doesn't work is that socket is not bound in the current context. Maybe one other thing to try in most cases would be to see if we are inside an eval or an exec context, because from what I know, inside an eval you can only do a single statement and not multiple ones. So we can't really do normal import and then have this name bound to something in the current context. So what we can do instead, and let me try that, is to see what's the value of this constant is and supply directly. So let's search for that. I think it's one, but let's do something else. I don't want to import it, but I can do this with 6. Okay, so let's try it. Let's try with the 6 here. Okay, there was a delay. Maybe something happened. Nothing happened. Let's try it here as well. So this one worked. We had a DNS query. This one didn't. Let's double check. Let's do that. And wait a few seconds. Nope, nothing happens. So I don't know, maybe there's some kind of firewall, but it doesn't really make sense. Outbound connections were allowed in our scan, as we saw. And there's no other way to verify it with the same host, which would be PTT logger. So that leaves us with a sleep. So let's try that. So let's start with a sleep of not 50 seconds, but 5 seconds and see what happens. Okay, so that seems to work. Let's try to increase that. Okay, so we validated that the code injection is actually happening via the sleep. That's good. So we'll try to escalate that, see if we can get a shell. That might not be the case if we are in the eval context, or at least it will be harder to do because you would have to fit the whole payload inside a single statement. And we might be able to do some crazy Python stuff to achieve that, but it will take some effort. So let's try and validate that we are inside eval. One thing we can do is to let's try and execute 2 statements. So we'll trigger the sleep via 2 different 10-second sleep via 2 5-second sleep. See if this works. This didn't work. Let's see if it works in the terminal. Eval is defined. So let's try eval this. Actually, let's do 6. Okay, so this is invalid. I assume an import would be invalid in this context as well. Let's try that. Yeah, and a 1 + 1, that's invalid. Let's actually Python supports the semicolon as a separator, so doesn't want to do that either. So let's check the docs to So this seems to be confirming our hypothesis. So what the docs say is that eval can be used to evaluate an Python expression. And what it says here, lower, is that dynamic execution of statements is supported by the exec function. So for me, this implies that execution of statements is not supported by eval, but by exec. So let's try and validate that with this. So this works. Okay. Oh, let's try it with the bigger example. Let's not wait 10 seconds, but it's more or less 6. Okay, so for me, what this tells us is that we are inside an eval context. So all that we can do is to execute a single statement. With the added constraint that we can't seem to make any outbound network requests. So right now it might be possible to do something like exploiting a blind SQL injection, because we don't seem to have a way to get the output of our statement in the response. We only get this trace back. So we might be able to exfiltrate some data by doing some conditional checks and triggering sleeps based on them. But I'm not sure it's worth it right now. So we have proof that we can run code. We should still show some value by showing some actual impact, like extracting some data. So let's think how we can do that inside the single statement. So we know that we are running inside a Flask app. So let's see and try if we can extract the secret used for signing sessions. Okay, Flask. I'm curious if we have access to the app variable inside this eval context, and from there we seem to be able to access the secret. Just lost it. Oh, it should be app.config and then accessing the secret key inside this dictionary. So what we can do, we can't run ifs because that would be multiple statements. I'm curious if an assignment is counted as a statement. So let's try this. This doesn't work. So it's a statement, it's not an expression. Maybe we can use string interpolation. I'm not sure if we can use string interpolation inside evals. Let's try this. Okay, let's see if import is available. This time. Oh, no, this is wrong. Okay. So let me think how we can abuse this. First, let's try and trigger sleep if the app variable is defined within our context. We are making an assumption here that the app variable has the same name as in this example, but since it's pretty standard Flask, I assume it will. So let me think how we can achieve that. So I can do this. Okay. So we can do something like this. Import of time and then sleep for 5 seconds. If app is defined as don't, okay. App is not defined, we are expecting this here. Yeah, so we can use this as our oracle. So let's copy this one. Okay. And let's see if it works. So if app is defined, we're expecting to see a 5-second delay. Doesn't seem to work. Let's use it without app first. So it doesn't seem to work, but it works locally. It seems to work like this. So our single quotes. Nice. So now we have a way to trigger conditional sleeps based on some condition that we define. And we can use this to extract the app secret, for example, in the same way that you would extract data using a SQL injection. So what we will do here, we first get the length of the app secret by doing some sort of, I think the length is I think the length has a standard, the secret key has a standard length. So let's see, length. No, let's secret Let's see how long this is. No. That's 64 characters. It's more or sleep. Okay. Okay. And let's do this now. So if this one equals 64. So it doesn't seem to equal 64. Okay, so we can do a binary search now and find out the length of the secret. Then with that length, we would iterate through each character in the secret key and try to guess its value. That seems like a lot of effort, and I think we have enough to go for now. So let's go back to our report. Just one thing to note here, we could, with this oracle, we can extract any kind of data that the application has access to. So, I don't know, maybe interact with the database, but we already have a SQL injection, so that's not of much value. We could use this to read files. Maybe there's a way to get a shell, but that would be like a fun homework exercise to get a reverse shell in the context of a Python eval. That would be nice, a nice CTF challenge, but we won't do that now. Okay, so going back to our notes, we've explored this. And let's look at the details that the scanner put here and try to add some more context if we can. We would have to modify this since we can't reproduce it. So we assume that the firewall thing is happening. I would argue that the impact is just the same as in OS command injection. We might be limited, but we don't seem to be running in any kind of sandbox. Just the context of this eval will make exploitation harder, but not impossible. Okay, so this recommendation assumes that this functionality is needed. I would add some details and recommend the client that maybe they can get rid of that and implement it in some other way, or combine this with a sandbox. There are pretty good ones available and they are open source. Okay, so let's edit this one. This is critical. Okay, so let's take this. Actually, let's take this part. And leave the rest. Okay. So what I want to do now is add some more context about the impact. And what I will say is that the attacker has access to all the components that the Flask application is using, like the database, for example. And can modify the system, as he wishes, being limited only by the rights of the, let's say the Python process. Okay, let's try to add a reference. I was looking for something from OWASP, but I think we already have the CWE inside. So we have 95 and this is 94. Let's check what 94 is. 95. That's more accurate. Okay, so let's save this. And let's mark this as ignored. Okay, so we have that. Let's take another look at the scan report. And see if there's anything that we would want to make sure that we add to the final report that we'll send. So this SSRF is interesting. Okay, so let's try and generate our report. I'll try to have two windows. One that I use to go through the findings, and one where I add each and every one of them to the ones that I want to the report. So I'll add the Python code injection, SQL injection, and the cross-site scripting. Okay, let's choose just one window. My idea didn't really make sense. The SSRF, will add that. Actually, let's try and sort them by descending by the risk level. Let's do this. Okay, so that's better. The sorting didn't seem to work only at the page level somehow. We want to see the manual SQL injection in search. This is important. Don't really care about that. Oh, we lost. This one, this one. Okay, we should add that one as well. It is not really a vulnerability, just the way the app works. And then we have just some info stuff. We don't really care about that. So let's generate the report. Rent a docx. So I generate this. Now we wait. Oh, report is ready. So let's download it. Okay. Now I'll probably use the fact that we can use Google Docs to edit our docx reports. Let's drop it here. So we have our report here. The main and big advantage is that this was generated from us, from the work that we did throughout the pen test, and we don't have to manually write this from scratch. And a lot of it is customizable. When you start your engagement, as I said before, you can specify a lot of the details here and have them completed in the final report, the company name, the name of the engagement. Then what you decided with the client, like the contract, what is the scope, what are the objectives. You can add your methodology and all that custom stuff here. And then what the client will see is this. It starts with an executive summary of all the things that were found. And they have a high-level overview for management. Then just some titles for each of the vulnerability. So not much depth right now, just perfect for a high-level overview. Okay, and then after the overview is ready, you get a deep dive into each vulnerability. So there's 32 pages of vulnerability that you can just comb through. Everything is here that you saw in the platform. And what we would have to do now is to try and add some human touch to this report and make it fit our needs and wishes more. So for example, me personally, I would make this code block stand out more, for example, and this here. Then I don't think this is necessary. And for each vulnerability, I would actually start with the description of vulnerability itself and then the risk, and just then continue with the evidence. Oh, we have a typo here. I do this because not everyone that's going to read this has the same context as us. We set the context first, then give some evidence for what we found. So the actual next steps here would be to go through the formatting and adjust a thing or two here or there, but this is in pretty good shape as it is. Then, as you saw here, you can change the status of the review, so someone can do a review of it, the client will see that, and everyone who contributed. Okay, and then you can deliver this to the client, talk with them, have them fix it, do a retest. But this is in pretty good shape as it is, and it follows what you added to the platform. Screenshots, nicely formatted, code blocks, perfect. I think this is in pretty good shape. I'd definitely do some changes, but I'm I don't have to write this from scratch, like make all the tables, insert all the links, paste all the recommendations, add all the pictures in the right spots. This just saves us a lot of work. So I guess this is it from me today. Thank you for watching, and see you soon.